Hi, so you want to talk to computers? Yeah, that'd be pretty cool. You want to make video games? Yeah, that'd be pretty cool. You want to get rich? Yeah, that'd be pretty cool. Learn how to program. No! Why? It's hard. Why? You just Google stuff. Kinda. Oh, what is programming? I've said this before. What is it? Not code. What? It's all about problem solving and logical thinking. You have to understand the concepts and how to apply them. Okay, what about the programming language? That's just a tool. Is it important? Kinda. A majority of people focus mainly on the language itself and less on problem solving and logic.
Yeah, and that's something that I had to learn with. Like, the language itself doesn't matter. Think of the languages as tools you have in your toolbox to solve a problem. You know what I mean? So you don't want to think like, oh, what tool do I need? Do you want to know, oh, what problem do I have? So you can go in your toolbox and see what tool is going to help solve that problem. You know, just for blatant terms.
Logical thinking. Is that bad? Yes. Why? Because you'll end up in tutorial hell. Is that bad? Yes. Why? Because you'll never learn how to program. Oh, how do you study programming then? Don't try to memorize the language.
Yeah, so like tutorial hell is the only reason you get stuck in tutorial hell is because you think you're learning, but it's really like a crutch. I don't know if anyone's been injured. A crutch just makes you feel like you're walking, but when you remove the crutch, it's like all the weight now goes on that area that is not too strong, and you either have the strength to hold yourself up or you fall straight to the ground if you have an ankle injury or whatever you have. So yeah, tutorials are more like a crutch. You don't really learn anything. You're kind of just setting yourself up to fail, basically. Fail really nicely because you can end up doing tutorials for a long time.
Instead of trying to memorize the language, try to learn patterns, problem-solving approaches, and how different pieces fit together. So how do you get better at programming? You program. What? You do it. What? Program. Really? Yes. That's it? Yes. Really? No. What? Programming is a skill, okay? But we can optimize this. I'm lazy. I don't like hard work. Me too. I don't like to study for 8 hours a day. Me too. So let me show you how I like to take notes. I like to use Notion. Notion? Yes. Don't other apps exist? Yes. Why Notion? Because I've been using it for years, and I'm pretty comfortable with it. It handles everything I need, allows me to have everything in one place, it's easy to use, and most importantly, it's free. Oh, that's pretty cool. This video is also sponsored by Notion. Oh, you might notice my notes aren't exactly winning any beauty contests. Yeah, they're pretty ugly and simple. Here's the thing. I actually want to learn stuff, not make my notes look good. A lot of people like iPads, and that's cool, but it doesn't really work for programming, unless you get a keyboard and a mouse. Oh wait, that's now a computer, you complete idiot. Most people are using a computer. I don't want to get an iPad. And my handwriting is disgusting. Whenever I study, I want to maximize my time. Ideally, I want to learn as much in 2 hours as someone else does in 8 hours. If you're really a programmer, you should.
I don't know if it's me, but when it comes to note taking and stuff, I write down, well, maybe it's me needing to write better notes, but I write down the notes of things that I might forget. So if I write the whole entire code down and there's just this one specific point where I make it, let's say I'm doing a game, I make it where it moves up or back, I might remember that specific line of code because I might forget it, or that specific function, or I just try to take this snippet that I might forget and try to remember it. I don't try to memorize the whole code because the reason you don't want to memorize code is because it becomes like recyclable, reusable after a certain while. So you just want to remember the specific chunk you need. So when you write the code, you could immediately, it's like going back in your toolbox. You feel me? That's when you're like, oh, well, what language do I use? I use this language. But what snippets or what chunks do you have that could solve the issue you're going through right now? Little things like that. So I don't know if my way of note taking or my code and stuff is different from other coders, but you tailor it to yourself. Basically, what I wanted to say.
You should already know where I'm going with this. I want to optimize my time. Let me introduce you to the Pareto
principle.
The
Pareto principle,
which is also called the 80-20 rule. What's that? It's the idea that approximately 80% of outcomes or results come from about 20% of your inputs or effort. What? A small portion of your work leads to a majority of your results. What? 20% of work equals 80% of results. Oh, cool.
I want to get...
Yeah, the parental method, the 80-20 rule, that's what I call it.
Crazy, right? Yeah. So, how do we apply this to studying programming? Well, we have to concentrate on areas where we get big wins with little effort. Let me show you how we do that. Whenever I study, I like to focus on core concepts. This is important. Instead of trying to memorize every method in a language, I focus on understanding the fundamental principles. Once you get those, the rest often fall into place. Why? Because of the 80-20 rule. These fundamentals will get you 80% of the results. When I'm studying new programming
That was helpful.
concepts, or really studying in general, I have specific questions that help me maximize my learning efficiency and understand core concepts. I call these my big questions. What is this? Why is this important? Why should I learn this? When will I need this? How does it work? Now, if you don't like these questions, you can create your own. It's simple. All you need is a what, a why, a when, and how. Now, why do I use these questions? They're not just random questions. They help me connect what I'm learning to other areas. It helps me understand where the subject fits into the bigger picture, and it also lets me subcategorize the topics. So let's say I'm learning something about object-oriented programming. The big questions would be, what is object-oriented programming?
You see, I don't know how much people watch it and just look at it for what it is, but for me, it just meant like I'm not learning languages because it's in demand. I'm learning languages because it fulfills a specific issue I keep running into with people I work with or something. Now, that's also why it's important to kind of just do projects so you know what issues you might run into over and over and over again. So you kind of reach this conundrum where you need work to get experience. You need like that type of stuff. Like you need experience to get a job, and they want 5 years of experience, but you don't have 5 years. Now you kind of get to at least learn this part because this part is important. You have to learn the frameworks, but the frameworks is important because you know what tools you got to use for the problems that may arise or may not arise. So you're really looking for issues that you think the world needs or has. And with those issues, problem solve your way out of it. It's almost like the opposite of a hacker. You know, like a hacker has to find vulnerabilities, you have to find problems to solve.
Why is object-oriented programming important? Why should I learn object-oriented programming? When will I need? I should have picked a better example, but you get the point. I'm not just copy and pasting or memorizing definitions. I'm trying to understand why this concept exists, but I don't stop there. If I'm given information about the topic, I take it a step further by turning the information into questions. This method allows my brain to actively engage with the material, which is way more effective than passive reading. So let's keep going with the object-oriented programming example. Let's say I learn what a class is, what an object is, and how to create both. I'd rephrase the information, which would give me, what is a class? What is an object? How do you create a class? How do you create an object? And then I'd also give myself my own questions. So maybe something like, what's the difference between a class and an object? If I'm actively asking myself questions, then I know I'm actually paying attention and not just brain rotting. It's like creating my own pop quiz, and if someone actually asked me that question, I would know how to respond. I like to rewrite definitions. I start with the original definition, then create my own version.
This is good. The reason I paused it because he's gonna have a different reason as to why he does it. I rewrite my definitions because it's easier to remember what I said than it is to remember what I read. Like that's just a me thing. So if I say the ball is red and it's upside down, that's what it means to be sitting. I could just be doing whatever. Like I'm trying to do something to make me forget it, or like a task, I'll just okay, music release on YouTube. That's what I wrote on the paper. But I just said the ball is red, the ball is down, and that's how you. Regardless, I'm trying to show you if you write your own definition, you'll remember it easier than if you have to remember what you read. Do you get what I mean? Because it's easier to remember what you said and come close to being right than because you're never right in programming, and that's the beauty of it. You're practicing ways to come close to being correct. You're not practicing ways to be exactly correct because if you're exact in programming and you're coming to me with an exact answer, I'm going to look I'm going to look at you and I'm going to be scared as shit because there's multiple ways to skin a cat in programming. Multiple.
I write my own definition. I try to meet two key requirements. 1. Would this make sense to someone else? 2. Would this make sense to a 5-year-old? I like the idea that you truly know something if you can simplify it. Now, not every concept has to. Now, all this note-taking and organizing is pointless if you don't actually write code. So I try to program, obviously. So whenever I'm learning a programming concept, I like to do this. I like to copy the code from whatever resource I'm using, so YouTube, a book, a class lecture, and then I create my own example doing the same thing. I try to notice if there's a pattern to it. Let's do an example. Let's say I'm learning how to fetch data from an API. So I copy code from whatever resource I'm using, and then I create my own example doing the same thing, and now I'm going to look for a pattern. And luckily for fetching data, there's some steps to it. Get your API URL, create a try-catch for error handling, create a response variable that fetches from the API, check if the response is not returning an error. If it is, then return an error. If the response works, then parse the data from it with dot.
Now I like the way he breaks it down, because the one thing about me is I know how to program, but I'm so unorganized with my notes. Like I could find a note here, 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 here. With this one, he's not even using the AI, and he kind of has a structured way of how he wants to learn. So definitely useful if you have unorganization skills with programming and organizing your code.
JSON. Yes, I'm using JavaScript. I don't care. As you can tell, this makes it really easy to understand a concept, but simple examples like this only go so far.
If you're a web designer,
It only goes but so far.
You also need to practice with real projects. I spend more time building actual projects than doing endless tutorials. This way, I learn by doing and reinforce my understanding of key concepts. And you all keep asking me, what's the best way to learn programming? Well, this is it right here. Just make projects. Literally, just code. It's that simple. Just code. I don't really take notes when I build projects. It's really just trial and error. But I do like to design and diagram things like my database schema, maybe classes, or I just visualize how the architecture would look.
See, for me, I wouldn't say, let me just take a picture of this, because this is good notes. I'm not going to lie to you. For me, I don't do this part properly. The architectural design portion, the classes, like the UML and the database schema. It's not that. I truly don't even know how to, you know what I mean? Because just, I do, but it's like, that's where I kind of get into the what's the easiest way to learn it. So probably go back into the start of the video and look at like asking the questions and go over these things so I do get it. But I just want to be transparent for the programmers watching. I don't know what the fuck this shit is. You feel me? And it's okay not to know what the fuck it is. Just figure it out. You know, that's the issue. I don't know what it is. My issue now is to go find out what these are, solve it, so I can be a better programmer tomorrow. You know, there's simple baby steps like that.
Visualizing really helps me understand how the project works, and it's a great experience because you're going to be doing this a lot. Alright, let's speedrun some other learning techniques. Number 1, active recall. Your brain is like a muscle. Now, most of you probably don't work out, and that's okay, but you need to work out your brain by testing it. Instead of just rereading notes, quiz yourself on whatever material you need to know. This is pretty obvious, but quizzing yourself will make you remember the information better. It's not a surprise. Number 2, space repetition. This technique is basically just taking gaps between study sessions and increasing the gap each time. This technique is based off the theory of the forgetting curve, which is just a fancy big brain way of saying the longer you don't study, the more you forget. Wow. So when you first start, you study the material, you take like 1 hour off, and then study it again, and then this time take maybe 2 hours off, study it again. Now take a day break, study it again, take a week break, study it again, blah blah blah. You get the point. You just keep increasing the gap. Space repetition helps flatten the curve, which means you don't forget as much, which means you don't have to.
Yo, you know what's crazy? Here's what I'm gonna say. I appreciate this video, but I listen to yourself, y'all. Because there's times where you feel like you're overbearing, or like you're trying to do too much because you're catching up. You're trying to, like, you know, like, and this theory right here just basically proves the more you exert, the more it'll show up as time progresses. So if you work at 100% for 16 days straight, at some point you're going to see a huge decline, theoretically. When you go from 100 to about 70, 60 every day, at least you flatline at 60% or 50%, however much, and you don't lose as much energy. You're able to rest. So rest. Even if you don't learn, like, just look forward to the next day. Use the rest moment as a way to learn as well. And there's different ways to study programming that's not too lazy, but this is a very straightforward approach as to how, you could be effective programming and not knowing too much, but still get a lot done, not doing too much. Work smarter, not harder.